Okay, so today we are going to start February March 2022 paper 1 2. Okay, there is only one variant February March session, and we are going to start with February March 2022. So let's start with question number 1. What number of protons, neutrons, and electrons are present in ion Fe3 positive? Okay, so it's iron with a 3 positive charge, and they have mentioned the neutron number only. So first you will take the help of the periodic table. When you look at the periodic table, you will find that its proton number is 26. Okay, you can check in the periodic table. So if its proton number is 26, then it clearly indicates the number of protons must be 26 in iron. Okay, so on the basis of this, I can easily mark option number C and option number D both wrong. Is this clear? Now, if we go for neutrons, so neutrons would be 54 minus 26, and if I think you would subtract both, you would get 28, right? So A and B both have 26 protons and both are 28 neutrons. So both options till this point are correct. And it have a 3 positive charge. 3 positive charge tells me that it have a 3 electrons less. So the total number of protons are 26. So if I subtract 3 from the 26, I would get 23, which makes the A option correct. Is this understandable to everyone? Yes. Okay. Now, let's move to question number 2. For which hydrocarbon are the molecular and the empirical formula the same? Okay. So we have to figure it out. It's butane. It's C4. And if it's butane, so it's CnH2n plus 2. So C4, 2 times 4, 8, 8 plus 2, 10. So C4H10 would be the molecular formula. Yes, it can be further simplified. So if I simplify it, I will get C2H5. So A is wrong. Ethane is C2H6, and it still further simplified as CH3. So B goes wrong. Pent 5-ene would be C5H10 because it's an alkene, so CnH2n, and it is also further simplified as CH2. So it is also wrong. So if you identify the first 3 wrong, then it clearly indicates that your last option is correct. And in exam, if you are sure that your A, B, and C are completely wrong, so there would be no need to, work on the D option. You can mark D correct and move further. For here, uh, let me show you. It's C3 and H8 as it's a propane CnH2n. Okay, so it can not be further simplified. It stays as C3H8. So D option is correct. I hope everybody understood, right? Okay. Now, Uh, let's move to question number 3. Which molecule does not have any 90 degrees on 180 degrees bond angle? Okay. So it's C2H6, an alkene. And in alkene, there is a 120-degree bond angle. So it goes wrong. CO2, it's a completely linear shape because of our two bond pairs and no lone pair. So it have a 180 degrees angle. So it also goes wrong. PF5 have a five bond pairs and no lone pair. So it have a 120 degree and 90 degree. Both the angles are there. So C also goes wrong. Okay, 1 minute. I have overlooked. It's have a 120 degree and they have asked you 90 degree and 180 degree. In the same way, D is octahedral and in this case, it have a 90 degrees angle. So D goes wrong as well. So our correct option will be actually A, because in A there is a 120 degree as it's alkene, and along with the 120 degree angles, it have a 109.5 degrees. Is this clear? Now, question number 4. It is related to enthalpy change. Okay. The following data are needed for this question. Okay. In the first part, if you see sodium hydrogen carbonate reacts with hydrochloric acid, forming sodium chloride, carbon, water, and carbon dioxide. And in the second equation, the enthalpy change is minus 38.97 kilojoule. In the second equation, sodium carbonate reacts with hydrochloric acid, forming 2 moles of sodium chloride. Okay, 2 moles of hydrochloric acid are reacting, forming water, carbon dioxide, and carbon dioxide. On heating, sodium hydrogen carbonate decomposes as shown. Okay, what is the enthalpy change of this decomposition? So you have to find the enthalpy change for this equation, right? Okay. And if you look at both the equations in the above two equations, this is the reactant over here, C, and the product that we are getting over here is present over here. And both are of these two are reacting with hydrochloric acid. So we can, make the Hess cycle accordingly, that when sodium hydrogen carbonate reacts with hydrochloric acid, sodium chloride would form along with water and carbon dioxide. In the same way, when sodium carbonate reacts, 2 moles of sodium chloride is formed uh, along with water and carbon dioxide. So here I can mark or label it as X. The reaction of sodium hydrogen carbonate with HCl for its enthalpy change is minus 38.97, and here 1 mole is reacting, but in this Hess cycle that I have made, 2 moles are reacting, so I can label it as twice of minus 38.97. And here, the reaction of a sodium carbonate with HCl produces 96.59 kilojoules energy. So if you look at these uh, arrows and the Hess cycle, I can conclude the equation or the expression must be equals to 2 times minus 38.97 plus x is equals to minus 96.59 and x would be equal to minus 96.59 and minus 2 times minus 38.97. Can anybody solve and tell me the answer, please? I think if I look at the equation, the values, it must be oh, 1 minute. 1 minute, please. Basically, 2 times minus 38.97 is equals to x plus minus 96.59. So x must be equal to 2 times minus 38.97 minus 96.59. Now, yes, who can tell me the answer, please? Okay. So the answer is 18.65 with a positive sign, right? So C is my correct answer. Is this understandable to everyone? If anyone have any doubt, do ask. Now, look at this question. Question number 5. In the redox reaction shown, how do the oxidation state of vanadium and sulfur changes? No, there is not a no difference. Okay. Yes, Sana. You can WhatsApp me if you have any query. Don't text on the chat. Okay. Virad, you also didn't understand this question? Yes. Now have a look over here. Examiner is asking you to identify the enthalpy change when 2 moles of sodium hydrogen carbonate on heating decomposes to form sodium carbonate, water, and carbon dioxide. And you have to find the enthalpy change of this reaction. Is this understandable? Yes. Now, if you look at equation number 1 and equation number 2, these two equations, if you see in this equation, this thing is present over here in the reactant side, and the reactant of the equation 2 is present over here So I can consider it as a product right now over here. Is this understandable? Now, if you compare uh, both the equations, in both the equations provided over above, which where I have marked them 1 and 2, you can clearly see that when sodium carbonate reacts with hydrochloric acid, you are getting 2 moles of sodium chloride, water, and carbon dioxide, right? In the same way, when this NaHCO3 reacts with HCl, you are getting these three products. Here we have a 2 moles. That's why we are getting uh, 2 moles of sodium chloride. Is this clear? I think that's what I am explaining, Sana. If you see, here we have a 2 moles of sodium hydrogen carbonate, and if I react with HCl, so I will be getting 2 moles of NaCl. And in the second equation, I'm already getting 2 moles of NaCl, right? So here Na2CO3 reacting with HCl forming 2 moles of NaCl. But here I have already have a 2 moles of NaHCO3, so I will be getting 2 moles of NaCl, okay? Is it understandable now? Yes, Virad, is it clear to you as well? Now, as 2 moles of sodium hydrogen carbonate are being used, so I will make it 2 times minus 38.97, okay? And here, I will just label it 96.59. So, now if you look at the arrows, you will uh, you can conclude or you can make the expression. The expression would be equal to 2 times minus 38.97 is equals to x plus minus 96.59, and x is equals to 2 times minus 38.97 minus 96.59, and if you will solve, you will get 18.65. Okay. Now, question number 5. In the redox reaction, shown, how do the oxidation state of vanadium and sulfur changes? Okay. So, if you recall, I have told you the rules of putting the oxidation numbers on the elements. First, put the oxidation number if the element is from 1, 2, and 3. Then put the oxidation number of most electronegative element. No, sorry. Then put the oxidation number on hydrogen, then on most electronegative element, and then any other element. Okay. So if we will work over here, this means that the net charge is +1 over here, and oxygen, there are 2 oxygens, which makes it -4. And if there is a -4 charge over here, which means vanadium must have a +5 oxidation number. Then the net charge is 0. Oxygen is minus times 2, minus 2 times 2. So here sulfur is plus 4. Here vanadium is already 3 plus. The net charge is minus 2. Minus 2 times 4 gives you minus 8, which means this sulfur have a plus 6. Is this clear to everyone? Yes. Now, what they are asking, I have a vanadium plus 5 to plus 3. So A and B goes wrong because these two are wrong. And sulfur is changing from plus 4 to plus 6. So C also goes wrong because these two are wrong. So the correct answer is B. Is this clear? Yes. Now, question number 6. The equation for the reaction between silver chloride and aqueous ammonia is shown. What are the units of Kc for this reaction? Okay, now if you recall, Kc is for the concentrations of the solution, and here it's a solid, so it is not be written in the Kc expression. So if I will write the Kc expression would be equal to concentration of silver ammonia complex times concentration of chloride ions divided by concentration of ammonia raised to the power 2. So if I work for the units, I will be getting mole per dm cube whole square in the numerator and mole per dm cube whole square in the denominator, which would cancel out. And finally, I will be getting no unit. So it means A is my correct answer. Is this clear to everyone? Yes, if anyone have any doubt, do ask. Okay. Question number 7. Sodium azide NaN3 decomposes as shown. Which volume of nitrogen measured at room temperature and pressure will be produced by the decomposition of 150 gram of sodium azide? Okay. Now, if you look at over here, in this, I can easily relate that there are 3 moles of nitrogen, which clearly means that the volume of nitrogen must be produced over here is 3 times 24 decimeter cube, and sodium is 23 and nitrogen is 14, and 14 times 3 would give you 28, 42. So is it 65? So 65 is the MR of sodium azide and NaNO3, but there are 2 moles. So I can write that 2 times 65 gram is producing 3 times 24 decimeter cube of nitrogen. Is this relation is understandable to everyone? Now, if I am using 150 gram of sodium azide, then the volume of nitrogen must be X. So if you calculate the X would be equal to 150 grams multiplied by 3 times 24 decimeter cube divided by 2 times 65 gram. So these two are going to be cancelled out. Can anybody solve and tell me the answer? I have just used the equation only. Examiner have given you the mass of sodium azide. So that's why I took the mass from the equation that there are 2 moles of sodium azide. So I take twice of the MR of sodium azide because NaN3 have the MR of 65. So according to the equation, twice of 65 gram of sodium azide is being used in according to the equation, and it will be producing 3 moles of nitrogen, but they are asking you the volume of nitrogen, so that's why I times it 24 to take the ratio between mass and volume. So I know this ratio. I got this ratio from the equation that 2 times 65 gram of sodium azide when reacts or decomposes, it will produce 3 times 24 decimeter cube of nitrogen. Is it clear, Sana? So if 150 gram is used, then X volume must be formed. So can anybody tell me the answer, please? No, you can take the ratio between two quantities, two different quantities. In the ratio, 2 units would be same and 1 unit would be different, or all units would be same. There are both the possibilities. Okay, so can anybody tell me the answer, please? Not all the ratios. See, we can take the ratio between two quantities. So when I am taking the ratio between the two quantities, obviously my 2 units would be same and 1 unit is different. But when I solve it, see the 1 unit that is different is left behind. And whatever the answer I will get, that answer must be in decimeter cube, right? Because the unit is left. Okay, can anybody tell me the answer, please? Okay, thank you, Variza. It's 83 grams. So you can calculate and check it's 83 grams. So it means my B answer is correct. Okay. Now look at question number 8. A stable ion with N5 positive has been produced by research chemists. Which structure is most likely to show the electron arrangement of this ion? Yes. Now it's for all of you. Look at each dot and cross diagram and identify which is the correct option for 8 and why. Okay, now I will tell you how you will identify which diagrams are wrong. It's more easier to work on which are wrong. First, include do's, exclude do's, then you will figure out why. Then you will able to figure out the correct one. Okay. So if I look at A, if you see over here, from this, what you can conclude, which bond is it? Yes, it's a dative bond, right? Because a pair of electron is shared by one atom. So if it's a dative bond is formed when there is no unpaired electron between the two atoms. If there is an unpaired electron, then the dative bond can never be formed. So see over here, you are observing an unpaired electron over here, right? So if there is an unpaired electron, so first that unpaired electron will make a covalent bond, and after that covalent bond is made, then the dative bond would form. So on the basis of that, I can mark A wrong. In the similar way, if you look at diagram B have a similar mistake that there is an unpaired electron over here and a dative bond is forming. So that goes wrong as well. Is this understandable to everyone? And that is the same mistake over here in B, that dative bond is there and there is an unpaired electron. So it goes, uh, so this A and B are wrong due to this. And if you look at in D, there is the same thing. There is a dative bond and an unpaired electron. So D also goes wrong, which means C option is correct. And if you work on C, you will not able to find any additive bond like this. And there is a one atom which have a one less electron. That's why there is a positive charge over here. Is this question clear to everyone? Now, question number 9. 1.8 gram of water heated to 27 degrees Celsius in a sealed container turns to steam with a pressure of 200 kilopascal. What is the approximate volume of container? Okay. So here you can use PV is equals to nRT and V is equals to nRT over P, where N is the number of moles of water, which are 1.8 divided by 18 multiplied by 8.31 is the gas constant, and T is the temperature, which must be in Kelvin. So 227 plus 273 divided by T. That is the pressure, which must be in pascals. So 200 times exponentially would turn into a Pascal. So just put the values in the calculator to tell me the answer. Yes, can any one of you calculate and tell me the answer, please? 2 exponent minus 3. Thank you, Ariza. So it means it is a B2 exponent minus 3 meter cube. Okay. Now question number 10. When the equation is correctly balanced, what is the value of C? Okay, C is H positive ions. Okay. In this question, N is basically moles, and moles is equals to mass over MR, and we are provided with the mass. Okay, Abdullah? And temperature is in Celsius, and here we use the temperature in Kelvin, and for Kelvin you have to whatever the temperature in degrees Celsius must be added with 273 to convert it into a Kelvin. Okay, so here they are asking when the equation is balanced correctly, that is the redox balancing thing, what is the value of C? Okay, so first place the oxidation number of the elements. Let me do it. So the net charge is 0, hydrogen is +1, and there are 4 hydrogens, which makes it +4. So it means there must be -4 on carbon, and there are 2 carbon. So each carbon have a -2 oxidation number, right? And here if you will work, the net charge is 0. It's +1 times 6, and it's -2 times 2. So it is -4, and here we have a +6. So it means there would be a -2, and each carbon have a -1 charge over here. So if you see, there are 2 carbons, each carbon have a -2 charge, turning into -1. So the change over here from one carbon, from the reactant to product, you can mark it as a -2 minus -4. So there would be a change in +2, the change in oxidation number over here. Now, if you mark the charge over here on Mn, it is +7 over here. And here it is +2. So Mn is changing from +7 to +2. So the change in oxidation number over here is would be -5. So see, they have mentioned you over here too, which means that this must be multiplied with 2, and this must be multiplied with 5. So 5 over here and 5 over here to balance the oxidation change in oxidation number. So here there must be a -10 change, and here the change would be a +10, which is indicating that the loss and gain of electron would be equal now. Now try to balance the rest of the equation. Now, if you see over here, the number of hydrogens over here would be 5 times 6 gives you 30 hydrogens, right? And if you work over here, there are 20 hydrogens over here. Now, the oxygens on the product side is 10. And here we have 8 oxygens. So it means there must be 2 over here. And if there must be a 2 over here, so 4 hydrogens over here. Now we have a 30 hydrogens on the product side and 24 hydrogens on the reactant side. So how many hydrogens are left? 6 hydrogens are left. So it means the value of C would be 6. There must be 6 hydrogens over here. So if there are 6 hydrogens over here, which means D is your correct answer. Is this clear? Yes. Is this question is clear to everyone? Yes, Variza. Okay, from where you didn't explain, Variza? You have to balance the redox equation as we did in the class. Okay. So if you balance the correct way, you will get the correct number of hydrogens. Let me show you how. See, even they have actually show you the hint over here. Just ignore this two over here for time being. Okay. Till here, is this clear to you? Till the change in oxidation number. Okay. So what we have to do, we have to balance the oxidation number. So for the purpose of balancing, I can multiply this by 2. And if I will multiply this by 2, then I have to put a 2 over here and 2 over here on both the reactants and the products which are responsible for this change in oxidation number of -5. Is it clear now? In the same way, I have to multiply this by 5. So if I multiply this by 5, so I have to put a 5 over here and 5 over here. Okay. Is this clear now? Okay. Now, when this is balanced, now we have to balance the rest of the atoms. Okay. So let's start with oxygen and hydrogen. Because we have already balanced carbon and manganese. Okay. We have already balanced carbon and manganese. Now let's start with uh so if you count hydrogen over here, you are getting 30 hydrogens, right? And further, if you count oxygen over here, you will be getting 10 oxygens, right? Now, if you count oxygen over here, there would be 8 oxygen, right? So 2 oxygens are left. To balance those 2 oxygen, you have to put 2 over here. So there would be 2 oxygen over here as well. And it balances the oxygens on both the sides. Is it clear to everyone? Now, you have to balance the 30 hydrogens. So there are 30 hydrogens over here. Here I have 4 hydrogens. Here I have put 5. 5 times 4 gives me 20 hydrogens, right? So these 20 and these 4 will make 24 hydrogen. And on the product side, I have a 30 hydrogen. So the number of hydrogens left on the reactant side would be 6. So it means that this C must be equal to 6H positive. Is it clear now? So if it is equals to 6, then the correct answer would be D over here. Okay. Now I hope it's clear to everyone. Yes. Okay. Now question number 11. The main stage in the contact process is an equilibrium reaction. Okay. Which law describe the effect of the named condition on the equilibrium yield? Okay. Presence of catalyst. Whenever we look at the catalyst, we know that catalyst doesn't affect the yield, right? It it just speeds up the reaction, but it cannot increase the yield or decrease the yield. So C and D goes wrong, right? For the catalyst, both of these are correct. Applying high pressure, see, all of these are gases, and when we increase the temperature, when we increase the pressure, equilibrium shifts in a direction where there are lesser moles of gas. So in this case, higher pressure will shift the equilibrium on the right side, because on the right side we have 2 moles of gas. So the yield of the product would increase. And here they said decrease yield. So this is the wrong statement, which makes A wrong, and it clearly indicates that B is my correct answer. Is it clear now? Okay. Now question number 12. Element X and Y are oxides of different period 3 elements. 1 mole of X is added to water. The solution formed is neutralized by exactly 1 mole of Y. What could be the identity of X and Y? Okay. First, they are saying that 1 mole of X is added to a water. The solution formed is neutralized by exactly 1 mole of Y. So, in case of A, if I add P4O10 in water, what I will be getting? 4 moles of phosphoric acid. Okay. And when I add aluminium oxide to it, 1 mole, let's see, I will be getting aluminium phosphate. and water. So if I will balance this, I have to put 4 over here and 2 over here. So see, the mole ratio is not exactly the same. So A is wrong. They have said that 1 mole of Y and 1 mole of X. So if I add 1 mole of SO3 in water, I will be getting H2SO3. And when H2SO3 reacts with Al2O3, I will get aluminium sulfide and water. And if I will balance this equation, I would have to put 3 over here and 3 over here. Now the equation is balanced. And if you see, the mole ratio is 3:1, which makes B wrong as well. Again, it's the same thing. I am getting 4 moles of phosphoric acid when P4O10 is dissolved in water. And when I react it with sodium oxide, I will get sodium phosphate. There are 4 moles of phosphate. So when I would balance it, 4. So I see 4 moles reacting with 6 moles. So C goes wrong. And it clearly tells me that B is my correct answer. But if you want to check, let's check. First, SO3 when dissolved in water would give you H2SO3. When H2SO3 reacts with Na2O, you will get sodium sulfate, Na2SO, sodium sulfite, and H2O. Now see, the equation is completely balanced and the mole ratio is 1:1. So D is my correct answer. In the above 3 cases, we are not getting the equal moles of both the X and Y. Is this clear to everyone? Okay. So for today, I will be keeping the class till here. Uh, Now, from here onwards, we will continue in our next class. Okay. Okay. Take care, everyone. Allah Hafiz.